This video is over Lesson 60, Polygons. Please take a moment to copy the title down into your notes. This video will continue in 3, 2, 1. The definition of a polygon has 5 parts to it. Think of this as like a checklist. You have to be able to check off all 5 in order for something to qualify as a polygon. So the first part, the polygon has to be flat. In other words, it cannot be 3D. 3D figures are not polygons. Moving on in 3, 2, 1. The second part of the definition of polygon is the figure has to be closed. And what this means is if I have a figure, there can be no way for me to draw a line from inside the figure to the outside without crossing over the figure itself. So this figure right here would be closed. However, this figure here, I can go from the inside to the outside without crossing over the figure itself. So this would not be closed. Also, if we had a figure that looks something like this, this would also be considered not closed, because even if I start in here, well, this isn't quite a line, but it still counts because I can go from the inside to the outside without crossing over my figure. So this as well would not be closed. So this might be a polygon, but these two definitely are not. Moving on in 3, 2, 1. The third part of the definition of a polygon is each side is a segment, which really means that each side has to be straight. So this is not a polygon. It does have 3 straight sides, but the fourth is not a segment. It's not straight. Therefore, the figure is not a polygon. Also, and it should be obvious, a circle is not a polygon because it fails this third part of the definition. A circle only has one side, and it's all curved. Moving on in 3, 2, 1. The fourth part of the definition of a polygon says each side intersects exactly 2 other sides, one at each endpoint. So if we have a figure that looks kind of like this, like an hourglass, this is not a polygon. Because if we look at this side right here, it intersects another side right there, a second side right there, and a third side right there. So it is intersecting more than 2 other sides, and one of those intersections is not at an endpoint. Now if we look at a different example, this figure as a whole technically is not a polygon, because we have an intersection right here which is not at an endpoint. However, most people looking at this would say that we have a polygon right here with a little bit extra sticking off. So what we would really think of this as is we would say this piece here is not part of the polygon. Moving on in 3, 2, 1. The fifth part of the definition of a polygon is actually a little odd, because if a figure passes the first four steps of the definition, then it is a polygon. The fifth part of the definition really only affects the naming of the polygon, and it says that no adjacent sides are collinear, and collinear means that they're part of the same line. So for example, this part of the definition is basically telling me if I have a figure that looks like this, I cannot consider this a four-sided polygon. I can't say that this is point A, this is point B, this is point C, and here's point D, so therefore this is a quadrilateral. Well, you know better. You take one glance at that and you know that it's a triangle, because this side here and this side here are collinear. They're part of the same line. So if we try to claim that this is a quadrilateral, then we have to say no to number 5, and so this violates the definition of a polygon. But if we call this just one side, now we're down to 3 sides and it's a triangle. Which is why the fifth part of this really does not affect whether it's a polygon. It really just affects the naming of it. You can't take one side and split it up into 2 just to rename it. So therefore, we would have to call this a triangle, not a quadrilateral. Moving on in 3, 2, 1. Polygons are named by the number of sides they have. You're going to receive this as a handout in class. However, I do want you to copy some of this down into your notes right now. I want you specifically to copy down the things that I expect you to memorize. And so I'm going to highlight that for you right here. These are the things that you need to copy down. From the number of sides column, I want you to know the names of any polygon that has sides 3 through 12 and 20 sides. And then I also want you to copy down what their names would be. That's all you need to copy down into your notes. All the rest of it, you do not have to copy down. So make a 2-column chart and copy this down. And obviously don't leave a big gap here. Just put 20 right after 12. And then copy this down in the second column. And that's all you've got to copy into your notes. So I expect you to know that a 3-sided figure is a triangle. That should be pretty easy. A 4-sided figure is a quadrilateral. A 5-sided figure is a pentagon. A 6-sided figure is a hexagon. 7-sided figure, you might not know this one already, maybe some of you do, maybe some of you don't, is a heptagon. A heptagon. 8-sided, you should all know, is an octagon. 9-sided might be new to some of you, that's a nonagon. 10-sided figure is a decagon. 11-sided figure is a hendecagon. A 12-sided figure is a dodecagon. And then finally, I'm pretty sure most of you have not known that a 20-sided figure is called an icosagon. So take a few moments, copy this down in your notes, pause if you need to. Moving on in 3, 2, 1. Now what you see on the screen is the rest of the handout that you're going to get in class. So you can see here that we have names for all kinds of polygons with many, 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 many different numbers of sides and going up very, very, very high. So we just talked about 20 being an icosagon, 30 is a triacontagon, 40 tetracontagon, 50 pentacontagon, pentacontagon, 60 hexacontagon, 70 heptacontagon. You may start noticing patterns here. Particularly tri for 30, and then we switch the prefix for 4 for 40, and it becomes a tetra. 5, we see that penta again. The 6 there, we see a hexa again. 7, we see a hepta. 8, an octa. And then for 9, we switch over to a new prefix for 9, which is ennia. So a 90-sided figure is an enneacontagon. 100 is hecto. 1,000 is chilea. Don't ask me why we don't use kilo. I don't know. 10,000, we use the prefix myria, so a myriagon, and this comes from the word myriad, which literally means to have 10,000 things. So a million, megagon, billion is a gigagon, trillion, a teragon, quadrillion is a petagon, 1 quintillion is an hexagon, 1 sextillion is a zettagon, and 1 septillion is a yottagon. Not Yoda. Not Yoda. A yottagon. Moving on in 3, 2, 1. On the back of the handout that you're going to get in class, you'll see this little chart as well, which gives some different ways of naming polygons with sides 20 to 100. It basically follows this formula. Choose the appropriate tens prefix, followed by and, which is chi. Choose the appropriate ones prefix, and put gon at the end. So down here you can see 24 sides. Well, the tens prefix is icasa, chi is and, tetra is the 4 prefix, and then gon. So a 24-sided figure is an icasa chi tetragon. 49 sides, tetraconta chi enneagon. And you can read through the rest of these when you get your handout. Now, in reality, as we get into these higher figures, we don't bother to actually find the real names, other than the ones that I'm asking you to memorize. The rest of these we would name much more simply in real life. A icasa chi tetragon we would actually just call a 24gon. A 49-sided figure, a tetraconta chi enneagon, we would really just call a 49gon. So this would really be an 88gon. This would be a 71gon. And this would be a 92gon. So for all those polygons that I did not ask you to copy down into your notes, that's how we name them. Write the number of sides, hyphen, gon, and that's it. Moving on in 3, 2, 1. Now we're going to take a look at some special polygons. Before that, we need to get some vocab terms down. And the first term we need to understand is congruent. Congruent means that two figures have the same shape and size. Now inside a figure, you're going to have angles and segments. The angles control the shape. So if two angles are congruent, it means they have the same shape. The segments control the size. So for two segments to be congruent, it means they have the same length. The next term we're going to look at is equiangular. Equiangular means all inside angles are congruent. A great example of this would be a rectangle. Since all the inside angles are right angles, all rectangles are equiangular. Our next term is equilateral. A polygon is equilateral if all segments are congruent. In other words, they all have the same size. A great example of this would be a diamond. And if we put the two of these together, we get a term called regular. And a regular polygon is a polygon that is both equiangular and equilateral. Moving on in 3, 2, 1. You do not have to copy these down, but here are some examples of regular polygons. In a regular triangle, we can see that it's both equiangular, so each of the angles has the same shape, and equilateral, so each of the sides is the same length. A regular quadrilateral is actually a square. All four angles are congruent, so they have the same shape. They're all 90 degrees, and each of the four sides is the same length, so four congruent sides. Here's a regular pentagon, shaped like the Pentagon building. Here's a regular hexagon. Hopefully that seems a little familiar to you, kind of like a honeycomb. And then one that should definitely be familiar, a regular octagon. And the regular octagon, of course, is the shape of a stop sign. And just for fun, I threw in this guy here, which if you count carefully, you'll see that this is actually a regular icosagon. And so what I hope you see is that as the number of sides increases, our regular polygons start to look more and more like a circle. You actually may find it hard to believe, but the figure you see on the screen is actually a polygon. I know it looks like a circle, but this is actually a regular hectagon. So 100 sides are making this figure. But in order for it to fit on the screen, the sides have to be so small and the angle between the sides is so close to being a straight line that when they all come together, it looks pretty much like a circle. But let's zoom in a little bit. Here we see the zoomed in section of the bottom of our regular hectagon. And if you look really closely, you can see here's a side, and then there's an angle right there, and another angle there, and another angle there, and another angle there. Even this zoomed in, it's still really hard to see, but it's there. It really is a polygon. And I'll leave you with one last glimpse of our regular hectagon. And this video ends in 3, 2, 1.